Hello, you are welcome back to Code Simplified. And today we'll be talking about the stack data structures in C++. So the stack data structures actually follows the principle of FILO, which simple means the first in, last out. So this stack data structures can be seen, maybe let's say, for example, like the undo feature in our computers like this. Maybe let's say if I open my Word document like this and I type something, hello, maybe let's say hello like this, you notice that this is the first action I've performed. But if I copy this and paste it like this and paste again, this in this case is the last action has been performed. But if I undo it, this will be the first action the undo will act upon. So the stack data structures actually acts upon the last element inside the stack before the first one. So if I undo it like this, you notice that the last action performed is the first one that the undo has acted upon. And then if I undo this, you notice that the next one before this, and then you notice that the first element, the first action performed will be the last one the undo action will act upon. So let's actually practically demonstrate what we meant by this on our text editor. So if you open your text editor like this in C++, in this case I'm using div C++ as my text editor. So for you to add stack in your program, you include stack like this inside your preprocessor over here. So over here, for us to define stack, we'll call, maybe we'll say stack and then bracket open bracket close. So inside here is where we'll be defining our data type. So in this case I'll be working on integer data type over here, and after that is where you define the name of your stack. So I will say my stack over here like this. So there are a lot of operations that can be performed on the stack, but for the benefit of this video, we'll discuss only 5 operations that can be performed on stack data structure. So we'll be discussing about the empty, which checks if the stack is empty function, and then we'll discuss the size, which return the size of the stack, and then we'll say push, which insert an element inside the stack, and then we have the pop, and then the pop actually removes an element from the stack, and the top, which actually returns the top elements inside the stack. So for us to use the empty function, let's actually check if the stack is empty. But for now we've not inserted anything inside the stack, so the stack is actually empty. So let's check if the stack is actually empty. So we say if, and then the name of my stack is stack dot empty like this, and then I'll call the stack.empty method upon it, and then I'll say, so if the stack is empty, it should print out for us stack, maybe let's say empty and empty stack like this, and terminate it. Else, if this stack is not empty, it should see out for us not empty, maybe let's say something like that. So over here, let's try to compile our code to see what we'll be getting. Let's compile it like this. It will give me an error. I've not spelled the include word. So if you compile it once again, so let's run that finish com. Everything is saying stack and empty stack rather, because we did not insert anything inside the stack is currently empty. So that is how to check if the stack is empty. So let's actually see out the size of the stack over here. So for us to see the size of the stack, we will first of all call the name of the stack, which in this case is my stack, and then pass the method or the function you want to operate on. So we use the dot to call the function. So let's say size. So it is, let's end the line over here so that it will display, it will break the line for us over here. Sorry. So let's say, let's compile our code one more time and let's run over here. So this is the stack is empty, and this is the size. You can see currently the size is at 0 because we didn't insert any element inside the stack. So let's bring something like this. The size of the stack is, maybe this is the size of the stack is like this. So if you compile and run, everything, the size of the stack is, it's actually giving me double zeros over here. Let me check to see. Okay, here's the problem. So after this, let's close it and compile again, and let's run our code to see what we'll be getting. Everything, the stack is empty, and the size of the stack is currently 0 for now because we didn't insert anything over inside the stack. So as it is said, the push, it is used to insert an element inside the stack. So for in case, let's call the name of the stack. To insert an element inside the stack, we will call the name of the stack, and then you call the push function. Then here you specify the name, the elements you want to specify. In this case, I want to pass in 1 inside the stack. So over here, let's compile and run over here to see our output over here. So as you can see now, because the stack is now currently empty, everything it has checked to see, and then it's saying that the stack is not empty, and then it's saying the size of the stack is 1 because we passed 1 element inside it. So it comes here and check if the stack is empty. This condition does not meet, so it kept this condition and printed this and print out for us this, and this one to check the size of the stack and print out the stack. So you can choose to do, let's add more elements inside the stack over here. So here you, maybe let's say 2, oh sorry, maybe 2, 3 or but you have to make sure that you insert an element based on the data type you have specified when declaring the stack. So let's see the size of the stack now. So let's run it and see the size. You can see that we've inserted 3 elements inside the stack. That is why it is giving us the size of the size of the stack to be 3. So over here, let's actually try the pop element, the pop function inside the pop function. So the pop function actually removes the first element inside the stack, as the stack actually, before we started in previous lesson, we say the stack follows the principle of flow, which means the first in, last out. So in this case, the first element won't be this one, but rather this, the last element. So it follows like this will be the first element before this one, so if you say my stack dot pop like this, it will remove this 3 from the stack because that is the first element inside the stack. It read downwards. So if you run your code like this. Let's compile it and run. You see it will give us the size of the stack to be 2 because it was 3, and then we'll pop. So if the pop will remove one element from the stack like this. So if let's see everything it is saying, the size of the stack is currently too big. Of course, we've called the pop function to remove one element from the stack. So over here, if we repeat this stack 3 times, you will see that it will give us an empty stack, over here, because the element you inserted are 3, and then you call the pop function 3 times to remove all the inserted elements. So let's compile it and see what we are actually getting. So let's run. As you can see, the stack is empty stack, and then the size of the stack is actually 0 currently. So as it is said before, let's go to the top function inside the stack. So we are done with the pop. So to return the top element inside the stack, you will say stack dot, and you call the top method. Is it top method? So if I run this code like this, it is going to print for me 3, because 3 is actually the top element inside the stack before 2, before 1. So 1 in this case it will be the last, and then 3 will be the first, because of the principle which follows first in, last out. So if you compile and run, it is going to print for us 3, because 3 it is the top element over here. So as you can see, this is it. I've no break. Let me break the line over here. Let me break the line. Let's run. You can see this is the top element that's written for us 3, and it's not empty. The size is currently 3 because we have inserted 3 elements inside it. So let's try to print out all the elements inside the stack for us to see something. So in this case, let's remove all this because we are done with it. So for us to print all the elements inside this stack, we can use the while loop to loop through the stack and print all the elements inside it to see that if the stack is actually holding 1, 2, 3. So we'll first of all see loop. So if while this condition will only runs while my stack, in this case my stack is not empty, over here like this. So it will see out, let's say my stack dot top. Let's terminate it, and then after seeing out the top element, it will remove the top element again, so that to left with this. So how this actually is going to run, let's run it like this to see what we are getting. So as you can see, it is saying 2, 3, 4. So let's add the end line to give us a nice display. So as you can see, this is the first element, so it has print 2, 3, 4, 5 because the first element actually begins downwards, so it will print this before going this. So how this loop actually will process before it will end, if the compiler is compiling the code and it gets to here, this while loop will tell the compiler, hey compiler, wait, I'm only told to run if this stack is not empty. So it will check the stack. If the stack is not empty, then it will run. So in this case, it will check if the stack is empty, If this stack is empty, in this case it is not empty, so it will allow the compiler to get into its block of code to compile it over here. So it will check if this stack is empty, then it will check. So this stack, it actually contains elements, so to allow the compiler to compile this. So if the compiler gets to here to compile it, to compile the top element from the stack, which it is this, and then after compiling the top element, it will break it, and then it will come here again, and then you see after printing out the top element, removed the top element again. So after printing out this one, it will remove this element from the stack again. So in this case, for the first iteration, if the compiler goes for the first iteration, it will print out this, and then it will move it like this, which in this case it will fly with only two elements, and then it will come back again, and then it will check if this stack is not empty. In this case it has remained two elements inside the stack, so this condition does not meet. It will run, it will get into it and run, and then it will come here and print out. So because it has left with only two elements, in this case this will be the first, this will be the top element inside the stack, and then it will run it, it will pass here and run the first element, which in this case it is 2. After running the 2, then it breaks and then removes the top element inside the stack again, and then it will come back and check if the stack is empty. No, the stack is still not empty. It has removed this one, all right, but it has left with one element inside the stack, so it will come back over here and check if the stack is empty. The stack is not empty, it has left with one element, and then print out the top element, which in this case is only one element inside it, and then to break and remove it again. So after removing it like this, so then now if it comes here, it will check if this stack is not empty. In this case this stack is empty, so this block of code does not meet, so it won't run. So it will execute to the end, return 0, which in this case the iteration has finished. That is why, that is how it has happened behind the scene before this stack has actually get printed. So let's print it one more time again to see our output. So as you can see, that is how it has processed. So for the first time it will print the first element, this 3, and then it will pop up, it will remove, then 2, then 1 again. So that is how the code will get executed before it will print for us our output. So let's actually write a function and then invoke the function over here to make it a little bit professional way. So let's actually write a function to invoke, let's actually write a function to print out the stack, the element in the invoke it inside the main. So void, and then over here the name of our function will come, let's say print stack, and then inside this we'll provide a parameter. So in this case, what parameter are we going to provide? It is going to take a stack, which in this case is to be the data type, and then we'll provide the data, the stack name over here inside as a parameter. Maybe let's say function stack by this over here, and we'll we'll open our curly bracket and repeat the, we'll check the condition if this function stack dot, if this function stack dot empty over here, it should see out for us the function stack dot top, and then after seeing out the top is a method. So actually call, after seeing out the top, we end the line, and then after that we'll function stack dot pop to remove the first element over here. So after defining the function like this, then we will invoke the function inside our main block. So we'll invoke, by invoking the function, what is the function name for the, let's say print stack over here. Then here we will provide the stack name over here as a parameter again, so that it will replace this over here like this. So let's run it and see what we are actually getting. Over here it is saying an error. They're saying I error is stuck. No, there's name. I've not spelled this correctly. Okay, it's from here. If I correct it like this, let's run again. Terminate it over here like this, and let's run over here. So let's print it out. As you see, it keeps giving us the same element, the same output as before. And so that is it. But please, if you find this video helpful, remember to like the video, share it, subscribe to the channel by enabling the bell icon so that anytime I upload a new video, you'll quickly get notified. And if you think you have any question, please leave it in the comment section below. Thank you for your time. Have a nice day. See you in my next video.